Our next speaker is a friend and colleague, Dr. Todd Maddox. Todd is one of the most dynamic speakers I've ever seen. Well versed with over 25 years of experience in psychology and neuroscience. He is currently serving as Vice President of Research and Development for Applied VR. He has over 200 published scientific articles, and he has a particular talent for being able to kind of take what is relatively complex science and make it understandable for the masses. So one of the things I appreciate the most is regular posts kind of updating us on the state of the science of different aspects of virtual reality, whether it's from how the brain works in learning in VR to how it affects different simulation models, behavioral health, pain management. It's really somebody I've learned a lot from over the years. Even though we've never met in person, I've learned a lot from Todd. In reading his various contributions. So, Todd, we're really fortunate to have you here today, and welcome.
Wow, thank you, Rob. That's super super nice. Really appreciate the super kind words, and hopefully I can live up to that. So no, the background is real. This is my guest room / office. I don't like when my ears look really funny when I have one of those virtual backgrounds. So this is me. This is real. Yeah. So Rob, hey, thanks for the invite, and everybody for being here. Appreciate the time. Hopefully I can live up to that introduction. So what I want to talk about today is the promise of virtual reality in healthcare. And I'm going to take a neurobiological approach. And for those of you that know neuroscience quite well, you're going to go, wow, that's really high level, Todd. And in fact, you're borderline on making this way too simplistic. Totally get it. That said, I think at the high level, we can really make a lot of progress and really understand why this amazing device, simply put, has the potential to revolutionize healthcare, in particular learning, because it's sort of a supercharged learning machine. Okay, so my talk is sort of broken into two parts. I'm going to start by talking again about sort of the neuroscience behind VR, broadly construed with applications in healthcare. And then I'm going to dive into the work that I've been doing at Applied VR for the past about a year and a half. And all right, so Rob already went through some of this, but just really quickly, yeah, I had a previous career, did the full academic route, loved it, wouldn't trade it for anything, but I was ready for a change, excuse me, about 5 years ago. And it's been really fun going from being kind of an expert in how to be an academician and run a university laboratory and write all these articles and write grants and such, to feeling frankly like overqualified in some ways and a neophyte in other ways on the corporate side. But I'm getting there, so hopefully adding some value. Okay, I know that this audience totally gets this, but I always like to start with a grounding, because frankly this helps me. There's a lot of realities out there. And if you start on the left, of course, there's the reality that we all live in. And let's think about what that reality is. It's a three-dimensional dynamic reality. So right here we have an example of a surgeon, but walking around in our environment, doing things that we do, we're walking around in this three-dimensional dynamic space. And our quote unquote reality in that space is basically constructed from our sensory and perceptual representation, right? So I can always present these cool illusions to you where, your interpretation of the world isn't exactly right, but of course it's evolutionarily advantageous. We can then start building these other kinds of realities, and in particular two. One is an augmented reality. So here you are in the real world, but you're wearing some sort of a device that allows you to augment that real world with some digital asset. And here we have a case with, a brain, and from a psychology standpoint and from a learning standpoint, This is really advantageous because that brain is this three-dimensional dynamic structure, which is what I'm comfortable with, which is what my brain is most comfortable processing. And then to the right, this notion of virtual reality, where I put on this device that frankly is getting more and more inexpensive and more powerful. I put that on my head, maybe I put some headphones in, and I am transported into a completely new reality. People often talk about virtual reality as tricking the brain. That's fine. I mean, I would argue the brain is just interpreting what's in front of us and doing a very effective job. So you can really, that brain thinks that you are in this new environment, which is really cool. And from a neuroscience perspective, what's happening is you're broadly engaging all these centers in the brain in the interest of learning or whatever task is in front of you. VR comes in two forms: 360 video. So basically a cool movie where you can turn your head, move your head around, and you see that environment changing just as you would in the real world, which is part of that sense of immersion, that sense of presence. Or computer graphic based virtual reality, where you're constructing these virtual worlds with super fancy code. And I'll show examples of both here. All right, I want to start with a quote from somebody who I've admired personally for a long time as a physicist, and tried to understand relativity theory. And I have to bring my daughter in to explain that to me because she kind of understands physics intuitively and I don't. But I didn't realize that he actually knew quite a bit about the science of learning. But no surprise, pretty smart guy. This is a really simple, straightforward quote that says it all, frankly. Learning is an experience. Everything else is just information. The idea being here, if I try to unpack this a little bit, is that we have evolved to learn best through experience. So learn by being in a rich context where all the information in that context is directed toward whatever learning that I have in front of me. And I want to be really clear here that when I'm using the term learning, I don't just mean education, and I'm not trivializing education. I want to be really clear about that. But I'm talking about learning more broad-based. So I can read every textbook that there is on how to play tennis. That's information. Does that mean I know how to play tennis? No. How do you learn how to play tennis? Through experience. You actually get out there and you engage all these learning centers in the brain that provide this experience. So we have evolved to learn through experience. That's what's really important. And what I want to do is provide sort of the foundation for that. Why is that the case from a neuroscience perspective? And then what do we mean by everything else is just information? And I want to be really clear that information is super valuable. I'm not discounting it. It's just not as effective for learning. This is information right here, right? And I'm old enough to remember when these devices didn't exist, but now we spend inordinate amounts of time in front of these devices doing things, for example, like going to a website and reading about how I practice breathing. So what am I doing when I do this? I am looking at two-dimensional static scribble, essentially, although it's nice and clean text. I've learned over my lifetime to automatically process these collections of this two-dimensional static scribble to immediately when I read the word breath, I know what that means, and it's automatic. I can't help but do that. But then I have to take this information, I process this information. In processing it, I have to store it in short-term memory. I have to rehearse it. I have to make sure I don't exceed short-term memory. I have to make sure my attention doesn't wane and go off to something else. I have to rehearse that information in hopes of getting it into long-term memory. And then I need to take that information and hopefully convert it into behavior. Needless to say, every one of these steps is non-trivial. And as I like to say, is a chance to fail. What about the neurobiology underlying this? Again, very, very overly simplified. But when I'm processing information, what happens is that information is being processed primarily by the prefrontal cortex, which is right behind your forehead. This is one of the most evolved brain structures in a human. It's what sets humans apart from many non-human organisms. It is a truly remarkable brain structure that you could spend your life studying and be completely blown away by. But it has its limitations. It has its limitations with respect to working memory capacity. So the old 7 plus or minus 2 bits of information. Executive attention, we have attentional constraints. So processing that information, you have to be careful. Bring it in short bursts, rehearse it, walk away from it, come back to it, sort of test your memory of it, all in the interest of learning that information, processing it, and ultimately getting it into long-term memory. And that is that is very challenging. I'm going to show you really quickly now a quick 25-second-ish snippet from a VR experience that we use at Applied VR. You're not, it's going to be static. Sorry, it's going to be dynamic, but it's going to be 2D. And you just have to envision, well, what if I was in VR? Well, I'd be able to look around and, I'd feel very immersed. But I want to show you a little bit more about, well, how would experiential learning work in this domain? And I'm going to start this.
Breathe slowly and effortlessly, in through the nose and out through the mouth. And with each exhale, send the tree your life-giving energy. It's working. The tree's growing. Remember, breathe slowly and peacefully. Keep going.
Cool. So again, you don't feel the huge immersion and presence you would in VR. But what's going on here? You've got this again, in VR, this immersive, rich context. You've got the voiceover that not only engages sort of emotional centers and is very soothing, but also is providing information. So you're getting that cognitive component. It's also highly interactive. The little blue blobs that were going toward the tree are actually linked to your breathing. So the Applied VR headset actually has a faceplate on it that captures your breath, and that is then converted and influences the experience, with respect to the tree. So that's an example of experience-based learning. And again, idealized, but this is your brain on experience. The point that I want to make here is that you don't just have these cognitive centers engaged, but you have behavioral centers, you have emotional and motivational centers, you have these engagement centers, and critically, you have these sensory representation centers all engaged. I'm going to dive a little bit deeper on this over here in this next slide. So again, the purple here, that was those cognitive centers that I showed you with information. Your presence in context, that's your sensory and representation centers, occipital lobes in the back, parietal, temporal, sides, and top. So all of that sensory and perceptual representation machinery, that's critical to experiential learning. Those are the experiential learning centers. You've got the motivation and you've got the engagement component. And of course, with respect to that breathing, by linking your breathing to making that tree grow, we're actually training behavior. And of course, behavior is the gold standard. So we really want to try to train behavior, and you can engage those centers with this kind of content. You're not going to engage those with that mobile device and that information. Okay, great starting point. Highly recommend that initially, but this is going to be much quicker to change behavior, and there's data on this. Next slide. Okay, so from a neurobiological perspective, again, very high level. When you put that VR device on, you're broadly engaging all these centers in the brain. You're engaging them in synchrony. So you're spreading the wealth of that learning across the brain, and you're reducing the cognitive load. Cognitive load is critical not to exceed, otherwise basically you're wasting your time. So that's a neurobiological strength of VR. What are some of the other strengths that sort of add on top of that? There are at least three, certainly within healthcare. One is consistency of content. So done a lot of certainly reading in healthcare simulation. I mean, some of these healthcare simulation labs and such, absolutely off the charts, amazing. But one thing we find is that there's variability. And even your facilitator in let's say a simulation lab, some are going to be off the charts amazing, some aren't. Well, with VR, your content is consistent. So you find that best facilitator, you find that best simulation experience. That's what you generate, and that's what you present every single time to your healthcare professional or patient. So consistency. Available on demand. As I said, behavior change is the gold standard. We know you can't change behavior overnight. Behavior change is gradual, it's incremental, and it's subcortically mediated via dopamine. Long story short, it takes a lot of physical repetitions. If I have my device available on demand, I can facilitate that process. So I have this supercharged learning machine that I can use anytime I want, anywhere I want. Absolutely off the charts. And finally, at scale, I can have this put in front of a single patient or provider, healthcare professional, 100, 1,000, 10,000, 100,000s, the sky's the limit. Consistent content on demand at scale with a device that broadly engages the brain in all these fantastic ways. Lots of applications, obviously, of VR in healthcare. This is just a few. Pretty broad spectrum, though. Obviously, behavioral training. We can use these to do surgical training and such. And there are companies out there doing all of this. In fact, multiple companies doing all of this. Some beautiful work being done in mental health around PTSD, anxiety, and certainly other mental health disorders. And as Rob mentioned, I used to post every day. Now it's Monday through Friday, but I like to post an article, a peer-reviewed article, every day during the week. Pick one, a little blurb on it from my perspective, and get that out there. For one, I want to share. For two, it's a great way for me to stay up on things. And it's just been fascinating over the last few years to watch the explosion of research in all these domains, certainly in mental health. And of course, with the coronavirus, it's even skyrocketed more. But just some beautiful work. It's been a joy to watch this field evolve and the high quality science that's being conducted. Patient and provider education. I mentioned senior care here in dialysis. I do a fair amount of work, and I have a lot of interest in dialysis. This is kidney dialysis. Won't go into a lot of detail, although I could. But one of the problems there is that we have all these people on in-center dialysis, which is quite expensive. And equally importantly, your quality of life's not very good. So there's a push to get people to home dialysis, but there are a lot of fears to overcome. I can talk to a patient or a nephrologist, kidney doctor, kidney professionals can talk all day to patients. It's not really going to alleviate their fears. Put a VR headset on them. They experience a day in the life of a home dialysis patient, and they're ready to go. So this is a case, patient and provider education. Tons of work in wellness, interpersonal skills. This is one of my absolute favorites. In VR, you can walk a mile in somebody else's shoes. There's no other way to do that. So I can experience what it's like to have, microaggressions directed toward me, or I can experience what it's like to be in the middle of, Black Friday at Walmart, for example, and learn how to address that and deal with that in a stress-free way. So, really critical. And obviously treating pain, which is what I'm going to start to dive into now. This is what we do at Applied VR. We built a virtual reality program for chronic pain, and we've started with chronic lower back pain. Lots of details here. Bottom line is 1/3 of adults globally suffer from chronic pain. And this is not just in older people. It's not just in men or women. It's not just in a particular race or ethnicity. It's everybody across the board. Our mission is to empower patients with the tools to live their life beyond chronic pain. I'm highlighting empowered because this is something that I've had the pleasure of learning from my colleague, Laura Garcia, who is a clinician who works with us at Applied VR. Empowering a patient is critical. Giving a patient a device and saying, you're in partnership with this device, but you're in control of it. You put it on when you want. We're empowering you to help address your to help address chronic pain. Critical, and it works. Talk a little bit about the program. So we have an innovative digital technology for sure. We have the faceplate. That's cool. It's very user friendly. If you've seen our device, very, very easy to use. But we're borrowing from decades of therapeutic work, which is exactly the way you should do it. We know that outside of VR, meditation helps with pain, CBT, deep breathing, mindfulness, and their Cohen's D's, their effect sizes, again, in scientific research, are quite good. What we've done is we've incorporated that into our platform. We have an 8-week program with each week having a theme. So 56 days, average duration 7 minutes. This program was developed basically by Beth Darnall, who will be presenting later on today. And she'll actually go into obviously a lot of her own, amazing work, but she'll talk a little bit about some of the work that we've done at Applied VR, in particular on durability effects. The content is broken down into 5 sort of categories or types. And again, I'm going to show you a really quick snippet. These are very quick, but just to give you a highlight of each of these. And there's no sound to this. All gaze-based, really easy to use. Pain education, we tell you a little bit about the central nervous system, how pain works. Breathing, you saw this earlier. Relaxation and interoception, these environments, relaxing, giving you awareness of the body. 360 videos, hang out on a cool beach, swim with dolphins, and then distraction games where you're following, in this case, some fly or something, and you're getting points. Okay. The learning centers, there's actually some great work out there on localizing the learning centers in the brain. And initially surprising to me, and then as I thought about it a little more, hindsight is a wonderful thing. I wasn't surprised. The pain centers overlap quite a bit with the learning centers in the brain. Not perfectly, but actually quite a bit. So it makes sense that this learning machine, VR, that broadly engages all these areas in the brain could be effective with pain. So, how does this work? We have these therapies that have decades of science behind them. We know that they work. We put them into this device. That's sort of a learning machine that broadly engages all these centers in the brain in synchrony, spreading the wealth of that learning, reducing the load on cognition. And we're getting very powerful effect sizes at the end of our treatment in a RCT that we just completed and published with around 200 people, effect size of 1.3, which is actually quite good. Happy to share links to this work that's published. We're actually writing up the durability data, actually revising a durability paper now as we speak. I'm happy to discuss that with anybody. So again, this is just sort of rehashing what I had in the previous slide. We take all these individual therapies, sort of build them into our 8-week program with a fixed sequence, and we're getting Cohen's D's effect sizes that pretty much double any of those in isolation. And teaser for best talk, actually pretty durable as well. Okay, what I want to do now is talk about, so that was really high level. I didn't go into a lot of details, but a randomized control trial we completed actually during COVID, which was pretty remarkable. We drop shipped devices to these 200 folks' homes. We had an active control, which was a VR device. So, not standard of care, not treatment as usual, but we sent everybody a VR device. Our sham basically had a big screen TV in there with nature footage as our comparator to our EaseVRX device. What I want to talk about here is a pilot study that we ran recently with an unnamed payer with 65 and older individuals. We sent everybody the device. It had the 56-day program on it, EaseVRX. It also had a button for an on-demand library. So just think of, like your Netflix. If you gazed at that on-demand library, some tiles would come up, and you could say, I want to do 360 video. I really like swimming with the dolphins. I want to do that again. Or, wow, that game was fun. I want to go find that game again. So the fixed sequence, the therapeutic EaseVRX that we validated, but also this on-demand library, use it when you want. When you've got pain, you're feeling pain coming on, go ahead and use the headset. And we combine that, which is of course in your home by yourself, when you want it, with what we called a synchronous VR social support group. So people put their headset on, actually gazed at a social support button, and they were transported into this virtual room with other participants in our pilot study and a moderator. And I'm going to show you just really quickly, this was an early version. So this is a snapshot of what it was like. Again, this was in VR. So you had all the immersion and the sense of presence. Everybody could pick their own avatar. And we had, hundreds of things to choose from, as well as if you wanted to be like a robot, you could be a robot. So people came in with other individuals who were suffering from chronic pain. We had a moderator in there who talked about, what did you do last week in the program? Talk about how, what we were trying to do there. What was coming up? What can you expect next week? What's working for you? What isn't working for you? And then, of course, in every social support group, there was an exercise, a breathing exercise that was really, really relaxing. I'll just say that. That was sort of the highlight for everybody. But people got to talk about what worked. They got to talk about, what was going on in their life. That basically, social support. This was run during the pandemic. Again, it was sort of toward the end. So toward the end of this trial, some of these folks are actually getting scheduled for their shots, which was cool because these are people who hadn't seen their kids, who hadn't seen their grandkids. It was really kind of sad, but they all really looked forward to the social support. So we really felt like we're doing something nice for folks, and they really enjoyed it. Just some high level results. Oh, sorry. So this just lays out the program again, the 8-week program, and then you've got the VR social support once a week at the end of each week. And of course, also that on demand, which I mentioned. Quick highlight of the results. So before the trial started, we asked people to rate the intensity of their pain in the last week, as well as how pain interferes with activity, sleep, mood, and stress. We asked some questions around loneliness and isolation as well, pre. Then at the end of the 8 weeks, we asked the same questions post, and we computed percent signal change. For the pain metrics, the percent reduction in pain intensity or interference range from 35 to 47%. 30% is deemed clinically meaningful, and that's based on extensive research in pain. We also got almost a 50% reduction in loneliness and isolation. And that was driven, in talking to the patients, it was driven specifically by the social support groups, which was pretty cool. People shared their personal stories and their coping strategies. I had the privilege of, I wasn't in the groups, but I was in a lobby, so I could see what was going on. I could hear what was going on. It was the highlight of my week, no doubt. Full disclosure, broke down a few times. Some of the stories of what people were going through, losing friends and family to the virus, tragic. But what was cool was how these avatars got to know each other and supported each other. We were not able to provide contact information at the end, but I guarantee you, had we, you'd have some new friends, which was really pretty amazing. One last slide. This is a quote from one of the individuals in our trial or in the pilot. The daily VR experience helped me cope with the pain. The support groups helped me understand the overall aim of the program and to meet others with chronic pain. And lots of other quotes, from other individuals along the same line. So the daily VR, EaseVRX worked for people. The support group helped them understand the big picture. What's going on here. We're actually building that into the next iteration of the product. And they got to meet other people going through the same thing, which you just can't overstate the importance of that. And that is it. Thank you. I'm finished.
Thanks so much, Todd.
Right on.
We seem to be light on questions today. We're not getting any a lot of questions come through the feed, which I guess it's a little bit difficult in the virtual environment. But yeah, I was happy to be involved in that study with you, and it's just such a remarkable thing to be, ultimately, hopefully, making a dent in the opioid crisis, which we know is affecting so many people. So, I love that we've tackled the low back pain issue because it's the most common, reason people to seek healthcare, other than pregnancy. So, yeah, it's a really important thing, and I'm glad we're making headway there.
Yeah, right on. No, absolutely. And we're continuing to forge ahead, Rob. So
Love it.
with you at our side as usual.
Love it.
So thank you. Awesome.